July 12th marked the first known combat use of uncrewed surface vessels as offensive strike platforms by the U.S. military. The mission was carried out using Saronic Corsair USVs, highlighting the expanding role of autonomous maritime systems in modern warfare. U.S. Central Command stated on X, yesterday using multiple one-way attack surface drones, CENTCOM forces successfully struck a submarine and ship maintenance facility in Iran. 3 Corsair unmanned surface vessels hit the port at Bandar Abbas Naval Base, marking the first time American forces have employed sea drones in combat operations. Last night's strikes degraded Iran's ability to continue attacking commercial shipping. In this video, Defense Updates analyzes what is special about Corsair USV deployed by U.S. military to hit Iran's naval assets. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. Task Force 59 was key to this mission. Created in 2021, Task Force 59 serves as the U.S. Navy's innovation unit for evaluating and integrating uncrewed platforms and artificial intelligence into routine maritime operations across the Middle East. Initially focused on experimentation and concept development, the task force is now transitioning these technologies from demonstrations to operational employment. The recent combat use of autonomous surface vessels suggests that uncrewed systems are beginning to assume more active roles in frontline missions, rather than serving solely as surveillance or reconnaissance assets. Employing USVs as strike platforms offers several operational advantages. Autonomous vessels can engage selected maritime and coastal targets without exposing pilots or sailors to direct danger, reducing the demand on crewed aircraft and surface combatants. They also provide commanders with an additional attack axis, forcing adversaries to defend against threats originating from multiple domains simultaneously. This is where Corsair, a medium uncrewed surface vessel, MUSV, developed by U.S.-based autonomous shipbuilder Saronic Technologies comes in. Designed from the outset as a software-defined autonomous platform, Corsair represents a shift away from modified commercial boats toward purpose-built military systems capable of operating independently in contested maritime environments. Corsair occupies the middle ground between small expendable USVs and large optionally unmanned vessels. Measuring approximately 24 feet, 7.3 meters in length, the vessel is significantly larger than Saronic's earlier Spyglass and Cutlass platforms, while remaining compact enough for rapid transportation and deployment. The size allows it to carry a considerably larger payload while maintaining the agility needed for operations in confined littoral waters, archipelagos, and coastal regions where traditional warships may be vulnerable or economically inefficient to employ. One of the defining characteristics of Corsair is its payload capacity of approximately 1,000 pounds, around 450 kilograms. This enables the vessel to support a wide variety of mission modules rather than being optimized for a single role. The modular architecture allows operators to rapidly reconfigure the platform for intelligence, surveillance and reconnaissance, ISR, electronic warfare, communications relay, mine countermeasures, logistics support, or kinetic missions. Powering the vessel is a hybrid propulsion system that combines conventional fuel-based propulsion with electric drive capability. This arrangement provides multiple operational advantages. Conventional propulsion delivers the speed and endurance required for long-range transit missions, while electric propulsion enables low acoustic and low thermal signature operations during sensitive phases such as surveillance or reconnaissance. Hybrid systems also improve fuel efficiency and provide greater operational flexibility by allowing the vessel to optimize power generation according to mission demands. Corsair has a top speed exceeding 40 miles per hour, 65 kilometers per hour, allowing it to rapidly reposition between operational areas or accompany high-speed naval formations. Equally important is its endurance. The platform is designed to remain at sea for more than 7 days without requiring resupply, enabling persistent maritime surveillance over large areas. Autonomy lies at the heart of the Corsair program. The vessel incorporates Saronic's proprietary autonomous navigation and mission management software, enabling it to execute complex missions with minimal operator involvement. Rather than functioning solely through remote control, Corsair is capable of autonomous waypoint navigation, obstacle avoidance, dynamic route planning, and mission execution while continuously monitoring the surrounding maritime environment. Human operators remain in supervisory control, authorizing critical decisions while allowing the vessel to independently perform routine navigation and mission tasks. The platform is designed to operate in GPS-degraded and communications-contested environments. A significant engineering emphasis has been placed on open architecture integration. Corsair is designed to accommodate third-party sensors, communication suites, and payloads without requiring major structural redesign. The vessel's communications architecture supports multiple networking pathways, allowing integration into distributed maritime command and control networks. Through secure data links, Corsair can transmit sensor information in real time to naval headquarters, crewed surface combatants, maritime patrol aircraft, or unmanned aerial systems. Such connectivity allows the vessel to function as an extension of a larger distributed force rather than as an isolated platform. Corsair is particularly well suited for ISR missions. Electro-optical sensors, infrared cameras, radar systems, and automatic identification system AIS receivers can be integrated to build a comprehensive maritime picture while reducing the burden on larger naval vessels. The platform also has considerable potential in electronic warfare, EW operations. Equipped with electronic support measures or electronic attack payloads, Corsair could detect, classify, and potentially disrupt hostile radar or communication systems. Mine warfare and logistics support is another area where the craft can be utilized. The vessel could also support kinetic missions through the integration of various payloads, though specific details have not been disclosed. In the mission against Iranian naval target, the crafts were most likely used in a kamikaze mode. They sneaked into the Iranian port and blew up the submarine and ship maintenance facility. They were simply laden with explosives, which were triggered remotely. This was not the first operational deployment of the Saronic Corsair in the Iranian theater. The platform had already demonstrated its capabilities the previous month when a Corsair USV participated in the rescue of the crew of a U.S. Army AH-64 Apache that crashed in the Gulf of Oman after being shot down by Iranian forces. The mission marked the first known use of an autonomous surface vessel to recover personnel during a combat search and rescue CSAR operation. Corsair aligns closely with the U.S. Navy's vision of distributed maritime operations, DMO. Under this concept, combat power is spread across numerous network platforms instead of being concentrated in a limited number of high-value warships. Autonomous vessels such as Corsair can act as forward sensors, communications nodes, decoys, or logistics assets, expanding the fleet's operational reach while imposing greater targeting challenges on an adversary. By distributing sensing and mission execution across many relatively inexpensive autonomous platforms, naval commanders can improve resilience and maintain combat effectiveness even after sustaining losses. The platform is also relevant to the broader strategic environment of the Indo-Pacific. The region's vast maritime distances, numerous island chains, and increasingly contested waters require persistent surveillance over areas that would be prohibitively expensive to monitor using only crewed ships and aircraft. Autonomous vessels like Corsair can provide continuous maritime domain awareness while supporting expeditionary operations, anti-access strategies, and distributed force postures across the first and second island chains. The ability to execute kinetic attacks greatly adds to its utility. Corsair demonstrates how advances in autonomy, hybrid propulsion, modular payload integration, and resilient networking can be combined into a versatile maritime platform capable of supporting a broad spectrum of naval missions. While it is not intended to replace traditional warships, it serves as a force multiplier that extends the reach, persistence, and operational flexibility of modern fleets.